What's up, math scholars? Mrs. Harp here with another math video. Today we're doing 4-3. Make sure you hit like and comment and share and subscribe if you have not yet, because I'm halfway to 24 subscribers. All right. So today we are doing functions involving e. You probably never heard about e. Who's heard of pi? Raise your hand if you've heard of pi. All right, everybody. Who's heard of e? Yeah, nobody. Well, e is very similar to pi. It's an irrational number. Let's pull up our calculators and look for the e button, because everybody probably didn't even realize it was there. So you hit second, and then you hit division key, and then you hit enter, and that's going to be e. There you have it. And if you've never seen it, second caret key is pi button. So they're both in there. They're both very famous irrational numbers. So 2.71828. 2.71828. It goes forever because it's irrational. And it's called E after the guy who discovered it. It looks like the word Euler was his name, but it's actually pronounced Euler. He lived in the 1700s. But you might be wondering, how did he discover this really weird number, 2.718? What he was doing was problems kind of like we did last week. Remember last week when we were compounding interest? And if it was quarterly, you'd put a 4 in for n. And if it was monthly, you put a 12 in for n. Well, what Euler started doing, and you don't need to write any of this down, this is just tidbits for life. What he started doing was putting larger and larger numbers in for n. So he would put like 100 in for n, and then 1,000 in for n, and then 1,000,000 in for n. And the larger n got, the overall value of this equation was very, very close to 2.7182, and that's how he discovered the number. Pretty cool. So you might win Jeopardy with that tidbit of knowledge. Or not. All right. We're going to go ahead and simplify some expressions. We are not going to use our calculator on these ones. I will let you know when we're going to use our calculator and when we're going to get decimal answers. We're going to do these two just by using the property of exponents, the properties of exponents. So you've learned them earlier in the school year. I don't know if you remember them or not. Do you remember what to do when you have two variables? We're going to treat e as though it's a variable, even though it's the number 2.72. What can I do when I have two separate bases that both have exponents? Spencer? You can add them. So this would be e to the what? Good. And then I actually had a song that I used when we were dividing bases with exponents. Do you remember how it went? I'm so proud of you guys. My last class, nobody could remember. It's bigger minus smaller. Put the answer where the bigger live. Now, would I want to do 12 minus 3? No, those are normal numbers, so you divide them normally and get 4. But you do want to do 4 minus 3, bigger minus smaller. And then that would be 1, and the answer will go in the numerator, because that's where the biggest exponent had been originally. 4.3. And then tomorrow review, Thursday open note quiz. And then everybody will be a scholar because it's open notes, and everybody will get a good last grade to go in the grade book before the grades close. So it'll work out great. Let's try this one. What happens when the exponent is way out there outside the parentheses? Distributed in. So 5 will become squared, and then these two will get multiplied. It will be e to the negative 6x. So to clean this up a little bit, I would probably calculate out 5 squared and get 25. And then I'm never allowed to leave a negative exponent. So I also had a song to do with that. Do you remember that song? You guys are so scholarly. Yes. Flip and make it positive. And when I say make it positive, I mean make the exponent positive. So we will flip the e, and we will then make the exponent a positive. That's probably the best answer. So no negatives in your final answer. No negative exponents in your final. All right. Go ahead and try both of these on your paper. You can pause the video to try them on your own and then restart the video when you're ready to check. All right, we're back. So who would like to volunteer for a ticket for number 1? Let's go with Kylie. Perfect. So she added her exponents. Number 2, who's got the answer? Lexi. Perfect. Any questions on those two? What did you say? The 12 came from the 6 times 2. Okay. Let's do the calculator stuff next. It says use a calculator to evaluate the expression. So that means this time decimal answers are fine. So I'll pause the video and you can try this by yourself and then we'll be ready to check. All right, we're back. Who would like a ticket on part A? You typed this in. Nick? You? 10.87 is not what I got. Did you do e to the 4th power? Okay. Give him a second chance here. 54.6. All right, 54.6 sounds good. He rounded up. Here's your ticket. And then Spencer, part B. Point what? No. Did you do e caret negative 0.09?
Here, I got it.
Did you forget the negative maybe? I'm going to let Spencer try one more time. All right, we got the answer of 0.91. Sounds great. All right, I'm not going to have you write this down, but I want you to look at it with me. Using the E button, you can actually model both exponential growth and decay. If you use E as your growth factor and you have your exponent be an X, it would be growth. Does this graph look like it would have an asymptote?
Yeah.
Sure would, right there at 0, 0, just like last week. And then, interestingly enough, if you want to use E to model exponential decay, you actually make the exponent a negative, and it would be decay. Would this graph have an asymptote? Yeah, right there at y equals 0. So you'll have asymptotes just like last week. You can shift these right and left. You can shift them up and down, just like last week. So we'll look at a few examples, okay? Let's look at this example first. Go ahead and type it in, and we'll fill out the chart. I don't think my TI-83 people need the exponents around the parentheses around the exponent, but if you don't use parentheses, just check that your values match my value, okay? So, like, check that your first number is 2.78, and then 2.85. Is this matching what you guys are getting? A solid graph, then maybe you do need the exponents around the... Oh, okay. Solid meaning a good one. Okay. Okay. Lexi thinks you might need the parentheses around the 0.25 and the X. Oh, okay, then yeah. I'm rounding to the nearest hundredth.
I don't know why.
3 times e to the point... Oh, you know what? I have an extra 0 in there. Let's try this one more time. I am sorry about that. I know. That's why I was looking. I'm like, I didn't remember these values from last period, because I did the same problem last period. All right, here we go. See if this looks better. 1.42. 1.82. And so, Lexi, did you use the parentheses or not? And you were getting 11 without it. So if you guys have a TI-83, you do need the parentheses around all this stuff to keep that exponent as one unit. So thanks, Lexi, for the tip. And then I'll hit my graph, and it should be exponential growth. Where would my asymptote be? At 0, where it's always been living at, because it hasn't shifted up or down. And then they are asking for domain and range. Let's go ahead and practice that. Domain is where the graph can travel left and right. No, it can go left of 0. So it's all reals for domain. You were thinking of range. Range is 0 through infinity. Now we don't want to include zeros. Remember how I'm going to write that? A parenthesis. A bracket would include. So how's everybody's calculators doing? No errors or domain, window range errors or anything? All right, we have one more graph to do today. And it is this one. So before we even start, let's talk about the shift. Do you think any shifting has happened? Mainly the up and down shift, because that's the one that would affect the range. So what number affects up and down shifting? This guy. So this graph will have shifted up 1 unit from a normal exponential graph. Hopefully I do a better job at typing this one in. All right, hey UTI 83 people. I almost think you would need a double set of parentheses on this. Yeah, I would do a caret and then a set of parentheses here, and then the set of parentheses that they have there. All right, how are my values looking? 43.52, 21.09. Is that matching what you guys are seeing?
Yeah.
Perfect. And then we already talked about how it's shifting up 1. That's going to make our asymptote run at the equation y equals 1. 2, 2, there's a dot. 0, 5.48. You didn't get this? Let me pause this. Pause ourselves. All right, we're ready to answer domain and range. So what do you guys think for domain? All real, so negative infinity through infinity. And range is a little bit different than the last one because it's been shifted. What do we think? 1 through infinity. So it can't go below 1 because that's where that asymptote's at. All right, we have one more concept to go over, and that is do you remember last week we were investing money for a certain amount of time?
Oh, yeah.
And we are compounding it quarterly, and if it was quarterly, we put what in front?
4.
And what about monthly?
12.
And what about semi-annually?
2.
And what about daily?
365.
So today, our money will be compounding continuously, which means every single second of every single day of the whole entire year, you're getting interest. A tiny, tiny, tiny amount, but it's happening continuously. Think about it like a ball rolling, like tick, 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 interest, 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 interest. But so there's a brand new formula for that takes that E into account. So go ahead and write it down. The A is going to be your total amount of money. I think I just used a Y when I put it up on the board. I already have it up on the board. Your P is going to be that original investment again. It's called a principal amount of money, which is why they use P sometimes. Sometimes I use A for a starting amount. E is that button on the calculator, so it's not really a variable. You don't put anything in for E, you use the button. R is your rate. Keep in mind you still have to do it as decimal. And then T is time in years, just like last week. So whenever you see that keyword continuously, you'll use this different formula. All right, let's look at a sample problem. This person is depositing $4,000, so that's going to be their principal investment, their original amount of money, into an account that's paying 6% annual interest, compounding continuous. So I know they're saying the word annual. Don't let that mess you up. They're not compounding that money annually. They're compounding it continuously. So they're giving you that interest continuously. So we're going to use the new formula, which has the E in it. So P, E, to the R times T. What is 6% as a decimal? And then times 1. So on this problem, times 1 you could skip, but if you're going to put like times something and you're using a TI-83, use those parentheses there. Everybody else, you won't need to worry about the parentheses if you have a newer calculator. Let's go ahead and type it and see what we get. And everybody has found that E button successfully. If not, ask a neighbor where that E button is. 4247.35. Is that what we're getting? Perfect. Nope. You have to do your graduation lesson to see if you can graduate the lesson. Uh-huh. Do you think you can graduate today? Easy peasy. All right. So this is actually 3 problems, but to see if you can graduate, why don't you do problem B? Okay. And I'll pause the video and let you try it. All right, we're about to check to see if these students graduated. It's $2,500 for your initial investment. Since you did see that word continuous, you used that new formula we just learned about today. Did you remember to do 0.05 for 5%? And then multiply that number by 5. You would have thought I would have typed it in, huh? I was too busy talking about the upcoming snowstorm. All right, it is 3210.06. If I typed it in right, who graduated?
Me.
Awesome. So, hey, it is exam week, so I'm not really allowed to give you any homework. So the homework is going to be optional. So if you're thinking you want a bonus homework assignment, you can come grab it. It's the front side only. It says 4.3 on it. Don't take it in and throw it away, though, because on the back we have next week's homework, which won't be optional. So come grab it if you want it, and you have a free night if you don't want the homework, okay?
Nothing to do with what
Front side only.